All right, sports fans. Since we're in the middle of the baseball playoffs, we can talk about sports fans. This is the 8th media computation video, and we're going to get rolling right now because this is actually a pretty short one, I hope. So what we're going to talk about today is how to copy pixels to a new picture. And in order to do that, what you need to do is you need to track the source picture, the X and Y components of that source picture, and the target picture. And so you'll have to keep two sets of X and Y variables, one for the source and one for the target. We can create a blank picture to use as the target picture. And actually in the media sources folder there are several blank pictures available. There's one that's called 640 by 480 JPEG. There's a 7-inch by 9.5-inch JPEG. You can also just use the new picture width, height constructor to create your own picture. So what we want to do is we want to start with a picture here, and we want to copy it into a target picture. And we're going to start by just copying, starting in the upper left-hand corner of the target. Okay. So in order to do that, we have to have a pair of nested loops, because we're going to loop through the columns first, and then we'll loop through the rows. Notice that this is a slightly different for loop. For one thing, the for loop statement itself is really long. But notice that we can use two loop control variables in a for loop. And so what we're going to do here is for the outer loop, where we're going to loop through the columns, we're going to have a source X and a target X. And we're going to start in the upper left-hand column of both pictures. And then we're going to copy the entire source picture. And so as long as the source X is less than the width of the picture, we're going to keep going. And then we're going to increment the source X and the target X. Oops, that should be TGTX. We're going to increment those every time through the loop. The interior one, we're going to do each row in that column. And so we'll start with the Y components. Again, we're going to start in the upper left-hand corner. So it'll be 0, 0, and 0, 0 where we'll start. We're going to go the entire height of the picture. So we're going to copy the entire source picture. And we're going to increment by 1 every time to get to the next row. And then the loop body goes here. So what's going to be in the loop body? Well, in the loop body, in order to do a copy, what we have to do is we have to get the original source pixel at a particular location. We have to get the target pixel at the equivalent location. And then we just get the source color from the source pixel and set that to be the color of the target pixel. And you're done. That's actually it. So this is pretty good. So if we look over here on BlueJ, we can put all of this together. And I'm just going to go down here and look at the method. So I'm calling this copy pick orig because this is the original one. And I start with two pixels, a source pixel and a target pixel that are empty at the moment. And my method has two inputs, the source and the target pictures. So I then do the columns starting with 0 and 0 for the source and target. I go the entire width, I increment by 1. Do the same thing for the Y to catch for all the rows. I start at the top, I go all the way to the bottom, and I increment by 1. And then I just grab the pixels, set the color, and I'm done. It's a piece of cake. And so we'll come back to this and we'll execute a bunch of things here. So that's the easy way to do a copy. But it doesn't give you a lot of flexibility. So there's another way to do it. What if I would like to copy the picture to a different location in the target? Say I want to start the copy at the target at 100, 100. I'm still going to copy the entire source picture, but I'm going to start it at a different place in the target. Well, that's actually pretty simple. We just have to specify 100, 100 as the upper left corner of the target picture. And you still copy all the source pixels, but the target X and Y start at the specified location. So yes, we just did that. Okay. So now what about, well, actually, let's go back and look at this. We'll look at this right here. So here's this one. So we're going to copy to a specific location in the target picture. Again, we start with source and target pixels. The signature looks a little different, though. Here's the source and target pictures, but here's where I want to start in the target. So my loop now looks like this. I'm going to start at 0, 0 in the source picture, but in the target picture, I'm going to start putting the pixels at these locations X and Y. And then I'm going to try to copy the entire picture. I'll leave it as an exercise to the reader, and you can grab this off of the Moodle page and take a look at it, to figure out why and when this won't work, because there's a specific place where this won't work very well. And I'll leave that to you to think about. Another way to do it is to copy the picture to someplace else in the target, but then deliberately crop the source picture so that we only get part of it in the destination. Okay, and so we're just going to copy part of the source picture to a new picture. In that case, what we have to do is change the start and the ending source values, their X and Y values, to the desired values. Basically, what we have to do is designate the upper left-hand corner of where we want to start copying the source and the lower right-hand corner of where we want to end in the source. And then we have to do that. But the problem is now we're in a particular position where we now have 3 methods to do the copying. We have the original one, which just copies the entire picture. We have the second one, which may have some problems, which copies the entire source picture, but it starts at a different location. And now what we want to do is we want to have a method that will copy possibly only part of the source picture onto the destination. And so this seems like more work than we should do. And in fact, it is. Okay, so let's step back for a second and ask ourselves the question, what makes a good method? Right? And so the primary thing that a good method in Java primary characteristic it should have is it should do one and only one thing. It should accomplish some task, and the name of the method should tell you what it does. In addition, a method can call other methods to do some of the work, which is known as procedural decomposition. If you do something over and over again, you want to make a method of it. That's just that simple. Okay, and we shouldn't have the same code in several different methods. If we do have a copy of the same code in several different methods, we should create a separate method, and then just make the call. And then finally, a method should be in the class that has the data the method is working on. So the answer to this question, were the last 3 copy methods general, is no, because they had duplicate code. They were trying to do essentially the same thing with just slightly different parameters. So what we can do is we can create a general copy algorithm. And it's a method that copies pixels from a source picture into a target picture. We're given a start x and y and an ending x and y for the source picture. If the start x and the end x cover the entire picture, then the whole picture is copied. That's fine. If the start x and the end x are only part of the picture, then cropping will occur. That's where you take off part of the picture and just leave a central part. And then they'll be copied to a new picture with a start x and y. We don't actually have to designate a start and finish for the target because we know just how much we're going to copy in the start, in the source picture. But what we do have to do is make sure that if we run off the end of the target that we basically stop copying. Okay, and so the algorithm looks like this. You're going to loop through the x values. So we're going to do the columns, and then we're going to loop through the y values, and then we're going to get the pixel from the source picture. We're going to get the pixel from the target picture, and then we're going to set the color in the target pixel to the color in the source pixel, which is exactly what we did before. So let's code, shall we? All right, I'm going to do a couple of things here at the beginning. Go back to the top and mention a couple of things. I've changed the way I'm creating my methods and using them. You may have noticed that the methods that we looked at did not have the word static in their signature. That's because what I'm doing is I'm going to use another way of being able to copy methods, and I detail it right here. We also demonstrate a different way to add methods to a class that doesn't require all of them to be static, because actually static methods are really only supposed to be used across all instances. So what we're going to do instead is we create down here, our class name is copypick, and down here in the main we create an instance of ourselves. We create an instance of the copypick class. That way we can access all of the non-static methods in the class just by prefacing them with the object name, and the object name is copy. So we'll create an instance of ourselves. We will then select a file. We'll make the new picture. We'll show the picture. We'll make a blank picture as a target, and we'll make the picture exactly as big as the source picture is. We can change this later and make bigger pictures if you want to, or you can make them smaller pictures. Here's the original one that we did, where we just give it two pictures and it copies. And then here's one other thing. There's another method that we can use in the picture class if you want to save the pictures. We haven't done that before. So what you have to do is, it's just the name of the picture. In this case it's target. So there's our target picture. Target, there's a write method in the picture class, and you just give it the location of where you want the picture to be saved, including the picture name and the extension JPG, because it will save it as a JPEG file. And so we'll take a look at that. In fact, actually, since I think I may have already done this, I'm going to make this copy too. Okay, and so we're going to start by doing the original one, and we'll see how that works. And remember how the original one works. We just give it the two source pictures. We start in the upper left-hand corner of both the source and the target, and we copy the entire target. This time we're okay because we know that the source and the target are the same size, because I've created the target picture up here to be the same width and height as the source picture. So we're good to go there. So I can close that, and then I'll come over here and do main, and we'll pop up with that. We'll go to Dropbox, thunk, thunk, media sources, and I've got a nice picture of a beach. Think, think. And that doesn't take long. Notice we now have two pictures. This is the original. You can see the name of the original. This that has the word none was the anonymous new picture that we created while the program was executing. And then right down here, it just appeared, is the picture that we just saved. And if I double click on that, it'll open up in preview, and you can see that it's exactly the same picture. So now I have this picture actually is just stored in memory, and so it's going to go away. Boink. But this picture stays around because we just created it. Okay, one more. Here we are. We're going to leave these alone, and we're going to do the general one. I'm actually going to skip the position one. I'll let you take a look at that one yourself. But here's the general copying one. This one takes a while. Well, it takes a while to explain because there's so many input values. So here's the source. Here's the method signature. This whole thing is the method signature. The name of our method. It takes is input two pictures, the source picture and the target picture. It's going to return back the target suitably changed. And it takes in 6 more arguments: the starting and ending x values for the source, the starting and ending y values for the source, and the starting the starting x and y values for the target. We have a couple of source pixels here, and then we drop into the loops. The loops are equally complicated. Again, I'm going to have an x for the source and an x for the target. I'll have an y for the source and a y for the target in the inner loop. And then here's what I'm going to do to prevent myself from falling off the end of the earth. Here's this complicated test condition. X has to be less than the ending x for the source, but it also has to be smaller than the width of the picture, so that way I don't run off the width of the source picture. And then tx, the target x, has to be smaller than the width of the target picture. If any one of these fails, then the loop test will fail and we leave. Same thing here on the inner loop where we're going through the rows. We're going to start here with a target, the source start here with the target. We will stop if we get to the end of the y value that we designated, or if we reach the end of the source, we'll stop, or if we reach the end of the target, we'll stop. And the work we do is just exactly the same thing that we've always done. Thunk, thunk, thunk. Grab the 2 pixels, reset the colors, and we're done. So the copy itself is really easy. It's just setting everything up. That's hard. So let's go back up to the main. And I've commented that out. So we're going to notice I have my copy instance here. And so I have to preface every one of my method calls with the copy. Oh, if I don't, so let's delete this. And I try to do this, and I compile. It will give me the non-static method cannot be referenced from a static context. Okay, and so what if I do this, copy dot, and then it will compile just fine. Okay, so I'm going to take my original picture. I've made a target. I'm going to start at 0, 0 in the source picture, and I'm going to do the entire source picture, and I'm going to copy it into the target picture at starting at location 100, 100. All right, and so let's give that a shot, shall we? And oops, must not have turned off reset the Java virtual machine. All right, we'll try this again. There we go. So we'll come here. We'll find media sources. We'll just use our beach view again. Okay, now notice what happened, right? So here's the original picture. And what I did was I copied it to the target picture, which is here. And this location is 100, 100. It's 100 pixels over and 100 pixels down from the top. And so, and I've copied starting at the upper left-hand corner of the source. And so I copy until I run to the edge. I copy until I run to the other edge, and that's it. So this picture's now been cropped. I can change what I'm doing here anytime I want. I'll have to change the code though. I can leave that, but instead of starting at 0, I could start at 50 here and 80 here. And so I'll start at a different place in the source picture, and we'll try this again. Come on. There we are. And now notice, okay, so this time we're in the same spot. We start in the same spot, but you notice I've cropped the whole top part here. Okay, because you can see there's the top of that tree. There's that tree right there. Here's this building. And this little tree, instead of having nice lots of sky above it, is just right at the top. And so, and I also moved it down a little. So this is an easy way to crop pictures and an easy way to copy pictures. And we can also write them. The only other thing I wanted to show you this time around is another little trick, which is to flip a picture, turn it over, so that the pixels that were on the right will be on the left. And so it's like the mirroring stuff that we talked about, except the mirror is at the edge of the picture, and you look into it, and the picture is reversed. So that's what flip does. There's two methods here. There's a flip, which will create a new picture that is flipped, and then this one here, which will flip in place. Now, the reason flip in place is interesting is because you have to change all the pixels in the same picture, right? And so this, I remember we did swap. Well, this is a place where you have to use swap. I have a color, which I call temp. I have to grab the color from the target pixel. I then have to get the color from the source pixel and save it in the target pixel. And then I have to take temp and put it back in the source, so that I'm going to swap those two colors so that the picture will reverse. Notice also in the outer loop here, where I'm running through the columns, I only have to go halfway through. If I actually go all the way through, it will end up doing nothing. And you can think about why that happens. But by going halfway through, I get to flip the entire picture. Okay, and so this is not like a mirror, but because I'm in a mirror, I only take half of them and copy them onto the other half, and I lose the right half. In this case, I'm copying both sides, so it flips the picture. So actually, let's try this. And let's go back up here to main, and we will comment out this, and I'll uncopy this. So you'll be able to see what it's going to look like. We'll wait for a second. Compile, close, and this will be the last thing we'll do here. Main, go, and media sources, and we'll do the beach view again. So now watch closely. There, and 2 seconds later, it goes the other way, and I've just flipped the picture 180 degrees. But you notice we get the entire same picture. So that's just another little technique that you can use there. And I think that's pretty much it for today. Thanks for listening. See you later.